In this video, we're going to explore what is meant by the term square root. And to do this, we need to just do a quick review of something we worked on earlier this year, which was exponents. Now, just like other pairs of operations, addition and subtraction, multiplication and division, they usually occur in pairs, right? What we call inverse operations. So all that a square root is it is the inverse of squaring a number. And so to help you kind of visualize this, I've got a picture of a square down here at the bottom. Now, what you should be able to recognize right away is that the area of this square is 9 units. Okay, so the area is 9 units squared. And the side, the length of one side of the square is 3 units. And this picture kind of allows us to put those two ideas together. Based on the work we did with powers, we know that 3 squared is equal to 9. So that is demonstrated by this picture here, where we can see that if we have one side of a square that is 3 units and another side of the other side is also 3 units, then 3 times 3 gives us an area of 9, or 3 squared, the picture is a square, is 9 units. Well, square root just kind of asks the question the opposite way. It says, if I know the area of a square is 9 units, how long must each side of the square be? So in this case, we write this a little bit differently. We say, okay, well, we know the area is 9, and we want to find the square root of it. So that's this symbol here, and then that is equal to 3, because a square that has an area of 9 has a side length of 3 units. And that really, in its simplest form, is what a square root is all about. It does get a little bit trickier, though, because we also know from our work with integers that two negative numbers also multiply together to make a positive. So what that kind of tells us is that 3 is not the only number that, when multiplied by itself, gives us an area of 9, or gives us an answer of 9. Negative 3 also multiplied by itself gives an answer of 9. So here's where we start to run into some difficulties, because we need to be able to have a way to communicate. Are we looking for the positive square root of a number, or are we looking for the negative square root of a number? And here's where the symbols we use in integers are going to be really helpful. So let's just run through some quick examples here. And I'm just going to use the number 16 kind of over and over and over again here. So if I want to know, if I see something where it says 16, the square root of 16, what that's really telling me is I want to know what is the positive square root of 16. So unless it's indicated otherwise, the default is the positive square root. So that, of course, is 4. Now if I want the negative square root, the only difference is I'm just going to put a negative sign out front, right? Which, if you remember from our integer work, is kind of like the same thing as saying what is the opposite of the square root of 16, which is negative 4. And if I want to know both of the square roots, I'll indicate that by asking for both the positive and the negative square root of 16, which is equal to positive 4 and negative 4. So this is the notation I'm going to use to make it clear which square root I'm actually looking for. Now there are some tricky things that go with square roots as well. First of all, the square root of negative 16. And if you think about it, from our work that we did with integers, there are no two numbers that are the same that multiply to give us a negative, because a positive times a positive is a positive, and a negative times a negative is a positive. So the square root of negative 16 actually has no solution. There is no square root of a negative number. The only other thing that you might encounter is that square roots also act like grouping symbols. So I might have something where it says 25 minus 9 inside the square root symbol. So this is finding the square root of 25 minus 9. So I'll simplify the square root first, which is 16, and then lo and behold, it's the same as before. The square root of 16 in this case is just 4, because I know that I'm looking for the positive square root. What we're going to do is we're going to solve the following equation here. And it says, so we have n squared plus 32 equals 48. So just like any other equation solving sort of problem, we'll start by getting the variable by itself by canceling out the constant. So we'll subtract 32 from the left and subtract 32 from the right. So those cancel out, and we are left with n squared on the left, and 48 minus 32 is 16. Now, as I said earlier, every operation has an inverse operation. Addition and subtraction cancel one another out. Multiplication and division cancel one another out. And in this case, squares are canceled out by square roots. So we will take the square root of n squared to get the n by itself. And then property of equality says what we do on the left, we do on the right. So I'll take the square root of 16. So the square and the square root cancel each other out, leaving us with just n, and the square root of 16, and this is the only sort of tricky part you need to remember here. I know we just talked about how if we wanted to have the positive and the negative roots, we would have to show that with a symbol. The exception to that, though, is when you're actually solving an equation, because we don't know if n started off as a positive value or a negative value. And so we have to kind of consider both possibilities in this case. So if you're solving an equation, you have to remember to give both the positive square root as well as the negative square root. So there are two solutions when we solve an equation that has the variable squared.